Okay, the topic for this video is isotopes and average atomic mass. We already covered mass number, which is not on the periodic table. Now it's time to deal with average atomic mass, which is. Here are the objectives. Pause and peruse if you wish. Remember, atomic number is a whole number. It's the number of protons. It's identical for all atoms of an element, and you find it on the periodic table. Mass number, also a whole number. It's the number of protons plus the number of neutrons, and it can vary among atoms of an element, and that's what we're talking about in this lesson. So remember symbols and calculations. So looking at the way this is written, this is Be, that's beryllium. The 4 written on the left on the bottom is the atomic number. So it has 4 protons. It also means 4 electrons, remember, because atoms are neutral. Now you see the 9 at the top on the left, that represents the mass number. So just looking at the symbol, beryllium has 4 protons and it has a atomic number of 4, and then it has a mass number of 9. So I find the neutrons by doing 9 minus 4. It's kind of set up just like a subtraction problem. So it would be 5 for the number of neutrons. What are isotopes? Isotopes are atoms of the same element, so the same number of protons, the same atomic number, but they have different numbers of neutrons, so they have different mass numbers. Some isotopes are stable, and some isotopes are unstable. We will cover radioisotopes or radioactive isotopes all the way at the end of the year when we talk about nuclear chemistry. Here are isotopes of oxygen. You can see oxygen 16, oxygen 17, oxygen 18. Mass is different. Mass number is different. So the mass number is 16, 17, 18. The atomic mass is different. You see 15.9949, 16.9991, and so on. So the number of protons is the same, but the number of neutrons is different. And you can see for oxygen, all of those isotopes are stable. Now let's look at neon. All the isotopes are stable, but we have neon 20, neon 21, and neon 22. Those are the mass numbers. And you can see the list of the number of protons, the number of neutrons, the number of electrons. Protons and electrons is the same for all the isotopes. The only thing that changes is the number of neutrons. The mass number changes, 20, 21, 22. Now if you look at carbon, we have 2 that are stable and 1 that is radioactive, which we'll talk about when we do nuclear chemistry. Again, the mass numbers, 12, 13, 14. The mass is the decimal number, the atomic mass. Okay. Number of protons is the same. You can see the number of neutrons is what changes. And then uranium. Uranium, 3 isotopes, all unstable, all radioactive. Okay. Mass numbers are different. 234, 235, 238. The atomic masses are different. Okay. Same number of protons though. Okay, so how many neutrons are in each isotope of hydrogen? So you can see the symbols written with the numbers on the left side. So on the periodic table, hydrogen has 1 proton. So for hydrogen 1, to find the number of neutrons, I do 1 minus 1. 1 for the mass number minus 1 for the atomic number. So hydrogen 1 has 0 neutrons. Hydrogen 2, I do 2 minus 1. 2 the mass number minus 1 the atomic number. So hydrogen 2 has 1 neutron. And then hydrogen 3, I do 3 minus 1. 3 for the mass number, 1 for the atomic number. So hydrogen 3 has 2 neutrons. How many neutrons are in each isotope of magnesium? Well, you check the periodic table. Okay, you see the atomic number of magnesium is 12, and then I have mass numbers of 24, 25, and 26. So for magnesium 24, I do 24 minus 12, so it would have 12 neutrons. For magnesium 25, it would be 13. And for magnesium 26, it would be 14 neutrons. Remember, you cannot find mass number on the periodic table. The value you see is an atomic mass. It's an average. This is not mass number. Atomic mass is a calculation based on isotopes of an element and their relative abundance, which is what we're going to talk about right now. Remember, isotopes, same atomic number, different mass number. Same number of protons, different number of neutrons. Same element. Isotopes are the same element. Okay, so that number, that's what we're going to talk about. How do you get it? Let's find out. So average atomic mass is a weighted average. That atomic mass, that decimal, it's a weighted average of all the masses of the naturally occurring isotopes of an element. The average atomic mass, that weighted average, is what's found on the periodic table. So atomic number versus mass number. The atomic mass is on the periodic table. It's a decimal, and it's the weighted average of all the naturally occurring isotopes. Mass number, which was in a previous lesson, is not on the periodic table. It's a whole number, and it's the number of protons plus the number of neutrons. If you are given the mass and abundance of each isotope, it gives you some information about atomic mass. So if we look up magnesium and we check its atomic mass on the periodic table, so you can see I've highlighted it there. The atomic mass should be between the highest and lowest isotope masses. So you can see up here, let me just grab my highlighter. Here is magnesium 24, and this is its mass. And then here is magnesium 26, and here's its atomic mass. So the atomic mass of magnesium should be somewhere between 23.99 and 25.88. It is, in fact. Also, the atomic mass will be closest to the mass of the isotope with the highest abundance. So let's look for the highest abundance in percent right here. It's this one. So that means the atomic mass should be relatively closest to this, which is basically 24. And it is. The atomic mass of magnesium is pretty close to 24. Okay, so the atomic mass of oxygen should be closest to which isotope? Check the abundance, which is the highest number. Okay, so the atomic mass of oxygen on the periodic table should be closest to that isotope, oxygen 16. Now check. Well, that's pretty close to that one. Okay, makes sense. Let's learn how to calculate that average atomic mass now. Now we know a lot of facts about it, but let's know how to calculate. Okay, here we go. First, change the abundance percent to a decimal. You move the decimal 2 places to the left. So there we go for 7.5, and there we go for 92.5. Multiply the atomic mass for each isotope by the natural abundance decimal. So I do this, atomic mass times the natural abundance percent. Okay, then I'm going to do the same thing for the next one. Atomic mass for that isotope, natural abundance. Add those two answers together. So I'm going to take these answers that I just got right here and add them up. And I'm going to get this. Check your significant figures. Okay, based on those numbers, I should have 2. Check the periodic table. Your answer should be close. Now, depending on how many isotopes are included, it may or may not be close, but this one is pretty close. Let's try another example. Okay, so here's nickel, and this time I have 4 isotopes, so sometimes you won't always have 2. So first we change the abundance percent to a decimal. So do that for each one. Change each one to a decimal. Then you're going to multiply the mass for each isotope by the natural abundance decimal. So you do that for the first isotope, the second, the third, and the fourth. Now I have to add all those answers together. So I've added all of these numbers here. Check your significant figures. I look, all of those have 4 significant figures. So it should be this. Now check the periodic table. Okay, again, it should be close. Like my answer shouldn't be 12 or 70, right? It's fairly close, okay? Now you're going to try. All right, calculate the average atomic mass of bromine. So see if you can do it. So pause the video and see if you can do this one. Then I'll go through it. Okay, so I change the natural abundance to percent, multiply it by the atomic mass. So I changed this abundance to a percent and then multiplied it by this atomic mass. Change this abundance to a percent, multiplied by this atomic mass. Add those numbers. So I added these, the answers. Check significant figures. I should have 4. Now I'm going to check the periodic table. Well, that one is really close. Okay, try again. Average atomic mass of chlorine. Pause the video and try it, and then I'll go through it. Okay, change the natural abundance to a percent, multiply it by the atomic mass. Then change this natural abundance to a percent and multiply by the atomic mass. Then you're going to add those answers and get this. Check significant figures. All of the numbers I'm given have 4, so that's what I get. Now check your answer. Look at the periodic table. Wow, that one is really close as well. And that's it. That's isotopes. Same element, same number of protons, different number of neutrons. Same element, same atomic number, different mass number. And then average atomic mass, that's found in the periodic table. It's a weighted average based on the mass of each isotope and its relative abundance. So that's it. I hope you learned something new today.